random variable. Suppose I have a sample space omega equal 1 to 3. Recall what sample space. Sample space means the set of all the possible outcomes. So that means x can only take 1 or 2 or 3. Can x take 0? No. Can x take 10? No. This x is not a set. This x represents a random variable. Let x be a random variable over omega with the following definition. So this is defining x. So this x equal to 1 with a probability half, equal to 2 with a probability 1/4, and equal to 3 with a probability 1/4. For example, you select x 22 times. So you have a 22 samples realization is like this. Because the probability of getting a 1 is half. So you should expect in this 22 samples, there should be more 1. There are 9 1, 6 2, and 7 3. So we expect 1 to appear more frequently because the probability of getting 1 is higher. This notation is saying that the probability of random variable x takes the value of small x in the sample space omega. So the probability of random variable x equal to 1 is half because of this. The probability of random variable x equal to 2 is 1/4. And the probability of random variable x is 3 is 1/4. What about the probability of random variable x equal to 5? Undefined. Or you can just say that it's 0. For random variable x equal to the small x and e, these two are basically the same thing. We are saying that random variable x takes the small x as the value as an event. And recall we have probability axiom. The first is probability of any event is larger than 0. So we can translate it as the probability of any random variable x takes whatever value larger than 0. The second axiom is probability of sample space is 1. It will be translated as the probability of random variable x takes whatever random variable small x within the sample space, and we take the sum, it will be 1. And lastly, for any disjoint event E, probability of their union is just the sum of each probability. We can translate it as the probability of random variable x takes whatever value in a set, where this set is union of a bunch of small sets. If these sets are disjoint, then the probability of this thing is the same as I take the probability of random variable x in this set, which gives us a probability, and then we take the sum over all this probability. Example, this translates to the probability of random variable x takes the value 1 is half, the probability of random variable x takes 2 is 1/4, the probability of random variable x takes 3 is 1/4. What's the probability of random variable x that is larger than or equal to 2? Well, it will be the probability of x is either 2 or 3. By axiom 3, 2 and 3, the two singleton are disjoint set, so it will be, by axiom 3, we can split this as the sum of probability that random variable x takes the value 2 plus probability of x takes the value 3. This thing will be equal to the probability of x is 2 plus the probability of x is 3. And by definition, this thing is this thing, which is 1/4, so we have 1/4. And this thing is this thing, so we have 1/4, so therefore we have half. So suppose we toss a fair coin 3 times. So let x be the random variable of the number of heads obtained. So now I want to find the probability of getting 2 heads and the probability of getting less than 2 heads. And the second question is, are the events that are 2 heads and less than 2 heads complementary? Are the events mutually exclusive? Let's find out. So let me recall in probability, whenever we start, we first need to identify what is the sample space omega. The sample space omega here is about tossing a fair coin 3 times. So these are all the possibility of the result of tossing the fair coin 3 times. How many of them? It will be 2 to the power 3, okay? Which is 8. Now let E be the event x equal to 2. What does x equal to 2 means? X denote the number of heads we obtain. So this is the same as what's the probability we get 2 heads. Then we will look at for the set E within the omega, how many of them fulfill this condition. Well, it will be these 3, HHT, HTH, and THH. So the cardinality is 3, so we have 3. How many elements in the sample space? 8. So the chance of getting 2 heads will be 3/8. So now let's say, let F be the event of x smaller than 2. So the probability of event F, where F denotes x smaller than 2, is the same as what is the probability? We toss a coin 3 times, we get less than 2 heads. So that will be what? 1 head or no head, right? So it will be 1 head like this, 1 head like this, 1 head like this, or no head. What's the size of this set? 4. What's the size of sample space? 8. So the chance is half. The second part of the question is, are the event 2 heads and less than 2 heads mutually exclusive? So recall that in probability, 2 events are mutually exclusive if the sets have no intersection. So EF are mutually exclusive since E intersection F is empty set, okay? If you intersect these 2 sets, there's nothing in common. So therefore, it's empty set. So they are mutually exclusive. Or in other words, if E occur, F do not occur. Or if F occur, E do not occur. And lastly, are these 2 events complementary? The complementary of event E is denoted as EC. Basically, it's the same as the whole set omega minus E. EF are not complementary because probability of F is half. And what's probability of EC? It will be, by definition, 1 minus E. So we know that E is 3/8. So if we subtract this, it will be 5/8. These 2 numbers are not the same, so therefore they are not complementary event.